In the problem statement, the object given is a cube. It is resting on the horizontal plane with one of its corners on it, such that the solid diagonal is perpendicular to HP and parallel to VP. Note, it is the solid diagonal, not the axis. For the given position, we can neither draw the top view and the front view because the data are not given in the problem statement. In order to complete the projection, we assume the cube is resting on the horizontal plane with its face on it. Draw the corresponding top view and then project corresponding front view, and in the front view we can find the solid diagonal and then tilt the solid diagonal such that it becomes perpendicular to HP and parallel to VP, and obtain the final front view and the final top view by projection technique. So to start with, draw the XY line. Since we are going to draw the assumed top view first, draw a 45-degree line. Along this 45-degree line, construct a square which represents the top view of the cube. Your cube side is equal to 30 millimeters and it has got 8 corner points. So we have shown 4 corner points A, B, C, D. So these points are put within brackets because these corner points are at the bottom and directly below the above 4 corner points. Those corner points are E, F, G, H. So E, F, G, H is at the top, and when you look from the top, they are visible, and the invisible points which are directly below these points are put within brackets. So now we have completed the top view corresponding to the assumed position. The question now is why the square is drawn at an angle of 45 degrees? Because it is given the cube is resting on HP on one of its coordinates. So if we draw like this, when we tilt the cube, it will rest on one of its corner. Suppose if we draw the square like this, after tilting it will lie on one of the edge or one of the side rather than a point. Therefore, this way of drawing the square in top view is wrong, and follow this. Now we need to obtain the front view corresponding to the top view drawn for the assumed position. So for that, draw projectors from each and every corner points. So from A, B, C, D, projectors are drawn up to the XY line because these points are lying on the horizontal plane. Therefore, their corresponding front view will be on the XY line. Therefore, on the XY line where these projectors intersect, obtain points A dash, B dash, C dash and D dash. So D dash is put within bracket because it is on the other side of the solid and we are looking from the front. B is nearer to us and it is visible and D is invisible, therefore it is put within bracket. The other points E, F, G, H are at the top. So what is the distance between the base and the top? It is equal to 30 millimeters because it is a cube. Therefore, draw a horizontal line at a distance of 30 millimeters above XY line connecting these projectors and obtain the points E dash, F dash, G dash and H dash. So H is on the other side of the solid which is invisible, therefore it is put within the brackets. Now we are going to draw the solid diagonal. So what is that solid diagonal? Draw a line connecting A dash and G dash. So this red color dotted line is the solid diagonal. As per the problem statement, this solid diagonal is perpendicular to the horizontal plane. When it is perpendicular to horizontal plane means this line A dash G dash must be perpendicular to the XY line. Right now it is inclined to the XY line. We need to make it perpendicular. And if you imagine, we will understand even after tilting or even after making the diagonal perpendicular to the XY line, that is perpendicular to the horizontal plane, the front view remains the same. That means its geometry and size remains the same, only its orientation gets changed. Therefore, the final front view can be drawn by reorienting the front view corresponding to the assumed position. How to draw that? Now we are going to make this solid diagonal A dash G dash perpendicular to XY. How to do that? Look at the problem statement. The cube is resting on HP on one of its corners, and we assume the corner on which the cube rests on the horizontal plane is A. Therefore, draw a perpendicular line, that means a line perpendicular to XY, whose length is equal to A dash G dash. So measure this length A dash G dash and draw a perpendicular line to XY, and as per our discussion, A dash is the point resting on the horizontal plane. Therefore, mark point A1 dash on the XY line and G1 dash. So we have made the solid diagonal perpendicular. So the distance between A1 dash and G1 dash is equal to A dash G dash. Now we need to obtain the points B dash, C dash, D dash, E dash, F dash, G dash, H dash over here. That means we are going to reorient the front view. For that, measure the distance E dash G dash, and with G1 dash as center, draw an arc. Similarly, measure the distance A dash E dash, and with A1 dash as center, draw an arc. So the two arcs intersect a point, and that point is E1 dash. So A1 dash, G1 dash, E1 dash. So A dash to E dash. Therefore, join A1 dash and E1 dash. Similarly, join G1 dash and E1 dash. On the same principle, obtain the point C1 dash, this point. So the rectangle is reoriented such that the solid diagonal is perpendicular to the horizontal plane. So what is left out? Left out is B dash D dash and F dash H dash. For that, measure the distance C dash B dash, or this G dash F dash, both are same, C dash B dash or G dash F dash. So measure this distance G dash F dash and transfer this distance over here from G1 dash, and this point is H1 dash and F1 dash, and through this point draw a line parallel to this G1 dash and C1 dash and obtain the points H1 dash, F1 dash, B1 dash, D1 dash. So the front view is reoriented like this, and since this is the final front view, it is drawn using thick lines. And note, when a line is perpendicular to one plane of projection, definitely it will be parallel to the other plane of projection. Here the line A1 dash G1 dash, which is nothing but the solid diagonal, is perpendicular to the XY line. Therefore, it must be parallel to the VP, that is the vertical plane. What is next? We need to draw the final top view. So how to draw this final top view? Draw projectors from each and every corner points on this face. Similarly, draw projectors from the corner points A1, B1, C1, D1. From the assumed top view, draw horizontal lines and obtain the points E1, F1, G1, H1. How to obtain this point G1? Already we have discussed in the earlier two problems. But again, if you want to locate this G1, follow the vertical line from G1 dash, and in top view here it is G, follow the horizontal line, both of them intersect, and that intersection is G1. Similarly, E1, F1, H1. Likewise, we can mark the points A1, B1, C1, D1. So while doing so, the point A, which is touching the horizontal plane, is at the bottom of the solid, and since we are drawing the top view, we are unable to see this point A, that means it is invisible, and hence A1 is put within bracket. All other points are visible. So now we can complete the top view by connecting the various edges. So first connect E1, F1, G1, H1, E1 back. So this is one face of the cube. All of these faces are visible, or edges are visible. And the next one is ABCD1, sorry, ABCD. For that, join A1, B1 like this. Here A1, B1 is dotted. Similarly, A1, D1 is dotted because A1 is invisible, and hence these two edges are shown as dotted line. Now what about the remaining edges? So here A dash is connected to E dash. So there is an edge. Where is this edge? Here. So this is A1 and this is E1. So join both of them, A1 to E1. So it's a dotted line because A1 is invisible. The next one is BF. So B dash, F dash. So B1 is here, F1 is here. Join them, B1 to F1. The next one is C dash, G dash. C1 is here, G1 is here. Both are visible points. Draw a line. The last one is H dash, D dash. So this HD. So D1 is here, H1 is here. So join them. And this is the final top view. This completes the problem. Thank you.